Okay, these are the notes for domain and range. It's keeping with our linear equations that we've been doing for a while. So here we have a swimming pool holds 648,000 gallons of water. When the drain is open, the amount of water in the pool drains out at a constant rate. So what I really would like for you to do is if you could read the questions, what is changing, which part are we controlling, which part depends on the other variable. If you could push pause and just kind of try to get those answers yourself, kind of think about it, you will learn it more deeply than just hearing me say the answer. So if you push pause now, even turn to a partner and talk to them about what you think is going on, and then you can come back, push play, and see how it's going. All right, what is changing? Well, the gallons of water in the pool, the amount of water in the pool is changing, and the amount of time, how long has the drain been open, that is changing. Which part are we controlling? We're going to control how long the drain is open. At any point, we can pull it shut. The amount of gallons of water in the pool is going to depend on how long the drain has been open. So our independent variable is time. That's the part we're controlling. I could open it up for half an hour and then close it up. It all depends on kind of what I need to do. The dependent variable is the gallons of water. Again, that depends on how long we've left the drain open. So back to the same pool, what are the limits on the amount of water? So when they talk about limits, decide what is the lowest amount of water you can have and what is the highest amount of water you can have. These aren't infinite in either direction. I can't have negative gallons of water. That doesn't make sense. And I can't have infinite amount of water. The pool is limited by how much it can fit. So the limits on the amount of water, the lowest amount of water I could have is 0. I could have no water in the pool. I can't have negative gallons of water. And the highest amount I can have is 648,000 gallons because that would mean the pool is full. So if the pool is draining at 2,000 gallons per hour, what are the limits on the time? So I know the limits on water is 0 to 240 or to 648,000. So if the pool is draining at 2,000 gallons per hour, that means every hour there's 2,000 gallons less than there was the hour before that. The lowest amount of time that we could have it open is 0. Like we can't have negative time. That doesn't make sense. I could just not open the drain. There would be 648,000 gallons of water. The time would stop when the pool was empty. So the time is not going to go on infinitely because at some point all the water would be empty. So how would we figure out what time the pool would be empty? So I made a little bit of a table here. So I know at time 0 there's 648,000 gallons in the pool. And then you can pick another time. Maybe you want to pick 1. Okay, so after 1 hour, I know I started with 648,000 gallons. And I'm going to subtract 2,000 gallons because every hour 2,000 gallons goes away. So now I have 646,000 gallons left. Then maybe say, you know what, that doesn't seem like it's going, let's try 10 hours. So I would take 648,000 gallons and subtract 2,000, but not 2,000, it's 2,000 each of those 10 hours. So I'm going to multiply it by 10. Okay, I'm multiplying it by 10 because it was 2,000 the first hour, 2,000 the second hour, and 2,000 for each of those. So that brings me to 648,000 minus 20,000, which is 628,000 gallons. Okay, and you can see I'm not going very quickly. So I could keep guessing here, and that is one way to do it, but it doesn't seem very efficient. Okay, I do see that I have a y-intercept right here. And I know my y equals mx plus b. I also know that I can figure out the slope because I have at least 2 points in the table. So, let's see if I can get this to cooperate. We have y equals mx plus b. We know slope-intercept form. I know the b. I know the y-intercept. It's right here. And the slope, I can figure that out. It's decreasing 2,000 every 1 hour. So my slope right here is negative 2,000, and my y-intercept is 648,000. So I plugged in my slope and my y-intercept. Well, when is the pool going to be empty? Well, the pool's going to be empty when the number of gallons is 0. When will that be 0? So I plug 0 in for y, and then I can solve that equation for x. And I figured that out, that will be at 324 hours that this will finally be empty. It's going to take a while. It's a big pool. But I think you can see using the equation is much more efficient than just guessing. Think how long you would have had to guess to get up to 324 hours. Again, to get my equation, I saw the y-intercept in the table. I knew what it was when x was 0, and you can just do 2 points to find slope. So just a reminder that domain is the possible values for the independent variable. Range is the possible values for the dependent variable. So the domain of our problem in algebraic terms is our time, which is x, is between 0 and 324 hours. We can write that algebraically by saying that x must be between, I'm hoping you have done inequalities before, 324. So this is it in words. It is between 0 and 324 hours. The time isn't going to go on forever. Again, I am limited by, at 324 hours, the pool's going to be empty. I'm not going to leave it open for 400 hours. I could, but nothing's really going to change. It's the end of my problem. For the range is the y's, and the y's in our problem was the amount of gallons in the pool. So this part, the range, is going to discuss the gallons. So for the y's, this was our number of gallons, and I can write that algebraically by writing that y must be greater than 0, but it has to be less than 648,000. All right, so Jeanette rents a bike while visiting a city. She pays $7 per hour to rent the bike. She also pays $8 to rent a baby seat for the bike. She pays this amount for the baby seat no matter how many hours she rents the bike. Okay, so just to talk about that a little bit, she doesn't pay $8 every hour. She pays $8 once for the baby seat. She pays that one time. Then it's $7 every hour. Her price goes up $7 every hour. So even if she gets on the bike, she puts the baby seat on, she rides a block, and she turns around and she says, you know what, I don't want to ride this bike. And you say, well, she didn't ride it even for an hour. She's still going to pay $8 for that baby seat. So that's kind of where that's coming from. I know a lot of you are going to think, well, 0 hours, it would be free. She's paying the $8. Once she signs the agreement, she's paying at least $8. So you're going to create a table of values for the situation. So remember, you need to determine what is changing here. So there's time, and there's also money. So I know at 0 hours, she spends $8. That's that situation I was talking to you about, where she got on the bike, she rode away, the baby's screaming, she's like, never mind, we're not doing this. They're like, well, you signed this contract, you're still paying us $8, even though you didn't even ride it for an hour. So what I would like you to do is push pause on the video and put in your own values for time in dollars. Now, remember, read this sentence right here. The rental store is only open for 8 hours, so your time here is limited. You can't put any old number in here. You are limited, so think about that when you fill in your time column, and then decide how to calculate the dollar column. That means our time is our independent. We're controlling that. The dollars is dependent. All right, you can see my sample here. You may have different ones. I didn't use the 0, but that's in here as well. All right, so create a graph of the situation. So again, your numbers in your table may be different, but you have points here, 1, 15, 2, 22, 5, 43. You have different ones. And we're going to graph the situation. Now remember, you don't need the big coordinate plane with 4 different quadrants because you don't have negative numbers. Negative numbers don't make sense for our problem. So you can just make kind of the one quadrant where they're all positive and then plot your points. So please push pause and do that now. Okay, you can see I did that here. Again, I didn't use all the different parts of the X and Y axis because I didn't need negatives. I put a point at 0, 8, and you can see I decided to count by 1s on the x-axis, by 5s on the y. You can see that here. Each box is worth the same amount, very important. So 1, 15, I believe it was 2, I think it was 22. And notice that I stopped it here, which is at 8 hours. I didn't put an arrow. It stopped here because you cannot rent the bike for more than 8 hours. So when you look at your graph, you should have a segment, and it should end at 8 hours on this way and end at 0 hours this way. That would be your range. Your range is your X's, 0 to 8. That's how far my segment went. And on my Y's, I didn't start at 0. I started at 8. 8 was my lowest Y, and my highest Y was 64 or 63. I forget what it was. 64. So we're going back into what are the limits on her independent and dependent variable in words? The time is between 0 and 8 hours. That's the limits she can rent. And her dollar amount, she's going to pay $8 even if for 0 hours, and she could pay up to $64. In algebraic symbols, again, it's right there. The X, because that's my time, is between 0 and 8, and my Y is between 0 and 60, or 8 and 64. So now we have another problem. Jenna is driving home from the beach. The distance from her house to the beach is 102 miles, and on average, she travels at a speed of 50 miles per hour. She is driving to her house. So every hour she drives, she's going to get closer to her house. So 102 is as far as she's going to be. So what is changing on the trip? Again, push pause and think about it. And which one's the independent, which one's the dependent? Push pause and take a guess. All right. The miles are going to change, and the time she's driving is going to change. The independent will be the time. Time is always the independent variable. If time is one of your variables, it's always the independent. And the miles will depend on how long she has been driving. What are the limits on her distance? So remember, what's the farthest she would drive and what's the lowest she would drive? Negatives aren't working here. We don't have negative distances. She's not going to drive forever. She's going to stop when she gets home. What distance is when she gets home? So her limits on her distance are 0 to 102 miles. 0 would be she's never left. She got a flat tire. She's still there. 102 is when she gets home. She's not going to drive 110 miles. Then she drove past her house. Now, for the time, I know her lowest time is 0. She can't go negative time. So her lowest time is 0. When will she get there, though? I'm not really sure when she's going to get home. So I know at time 0, she's 102 miles away. I know after 1 hour, because I can figure that out, if she goes 50 miles an hour, after 1 hour, she will be 50 miles closer. So 102 minus 50 gives me 52. Well, now that I have 2 points, I can find the slope. I can do the difference in the y or the difference in the x. So there's my slope right there at negative 50. Some of you may have been able to see that. What's changing, what's her rate of change? And I also have my y-intercept is right here. So I was able to get my equation. And then, okay, well, when will she get home? When her distance from home is 0, when she gets there. So I plugged in 0 for y, and I solved. So in 2.04 hours, she will be 0 miles from home. She'll be home. So the range on her time is 0 to 2.04 hours. And that is how we can show that algebraically. Again, the x is the independent. So the 0 to 2.04, that's where that's coming from, right here, from the time. And the 0 to 102 is coming there. All right, now this one is a little different. Verizon charges $4.99 to rent an on-demand movie. What is the independent variable and the dependent variable? Well, I can decide how many movies I want, and the cost on my bill is going to depend on how many movies I rent. What are the limits on the cost? Well, there is a limit of 0 because you know what, maybe I don't want to rent new movies. So I could pay 0 in terms of movies. But what's the highest amount? It's actually infinity. I mean, maybe you're going crazy and you're just renting movie after movie after movie after movie. You could rent infinite movies. So this is a little different. It does stop in one direction, but it doesn't stop in both. And this is to the range because cost is the Y value, the dependent. The number of movies in a similar way, well, I could rent no movies, but what's my highest amount of movies I can rent? Infinity. I could rent movies all day long. I could rent infinite movies. And this is called the domain. So this is available as you start to work on different problems. Come back to this, fast forward, rewind to get to things that you're not sure about.